Hi guys, so this is the second video on stationary and inflection points as part of the Math SL series on differentiation. In this video we shall continue with our analysis of the curve of f of x. We shall tackle these three questions, and I shall begin question number 1 shortly. So the first question came in paper 1, May 2002, question number 14. Kindly pause the video and attempt to solve. I shall begin my explanation shortly. So we shall begin by analyzing the graphs of f, which are on the left. Take a look. So for f1, I can see that the function was decreasing and then constant and then increasing. You can see that in red. Hence f dash was negative and then 0 and then positive. So I'm looking for a graph which started as negative and then passed through the x-axis 0 and then became positive. And the only graph that satisfies these conditions is graph D. Hence, we match F1 to D. And they've actually already done that for us. Next, I look at F2 and I realize that F dash goes from negative to 0 to negative. And the only graph that satisfies this condition is E. Hence, F2 matches with E, because f dash was negative and then 0 and then negative, and that corresponds to my analysis in blue there. F dash is negative, then 0, then negative. So function 2 matches with E. Now for function 3, you can tell that f dash, which is represented in blue, was negative, then 0, then positive, then 0, then negative, then 0, then positive. So the only curve which satisfies these many changes of f dash is this curve right there. And we can verify it was negative, then 0, then positive, and then 0 right there, and then negative, and then 0, and then positive. So this corresponds to F3. Hence we match F3 to B. Finally, for function 4, we can tell that it was negative throughout. The slope was negative throughout. The function is decreasing throughout. So f dash shall always be negative. And the only function that is always constantly negative is function A, correct? So we match f4 to A. Since the entire line or graph lies below the x-axis, so it is constantly negative. Another way of verifying what I said is to analyze the nature of each curve in another sense. So the first curve on the left at the top, f1, is a quadratic curve. So I expect a linear function. This is just for confirmation. This is not the main technique. It's just for confirmation. This is an x power 2 function, and it makes sense that my graph was an x power 1 function. The derivative was an x power 1 function, a linear function. So I went from quadratic to linear. Next, for function 2, I went from cubic to quadratic, and that makes sense, from x power 3 to x power 2. Then for f3, I went from an x power 4 function to a cubic function, and that also makes sense. And for f4, I have a linear function, so I expect my derivative to also be linear. However, instead of having a sloping line, I now have a horizontal line that is constantly below the x-axis. So this concludes our solution to the first question. Take a minute to copy this down if you will. I shall begin question 2 shortly. And the answers are right there in the table at the bottom of the page. So now would be a good time to pause. So the second question that we shall tackle came in paper 1, November 2006, question 4. Kindly take a minute to pause the video, attempt to solve, and then wait for the explanation shortly. So I shall begin by analyzing the graph of f as I usually do, and then we shall see which of these 5 diagrams correspond to f dash and f double dash. So take a look. So I've labeled the different parts of my graph in terms of f, whether it's increasing or constant or decreasing, and I've associated these labels with states of f dash, whether positive or 0 or negative. I've done my usual work. I've also identified regions where f double dash was negative and then positive, and I've identified my turning points in blue as well as my inflection point in green. So now that I've done that, this should be a pretty easy question to solve. I need to find the graph of f dash. So what do I know about f dash? I know that f dash went from positive to 0 at the origin, to negative, to 0 again, and then to positive. So obviously this is satisfied by I. Positive, 0 at the origin, negative, 0 again, and then positive. And since f is a cubic function, I expect f dash to be a quadratic function, and hence this confirms my solution of I. So what about f double dash? What do I know about f double dash? I know that f double dash is negative until this point. So before this green point, f double dash is negative, and after this point it is positive. So I begin by being negative. I'm looking for a graph that is negative at first and then positive later. So obviously triple I doesn't work because it began by being positive. So is the graph IV or V? This is determined by when is f double dash 0? At the inflection point, which corresponds to a positive x value. So for graph V, the f double dash equals 0 point is at the origin, or the inflection point is at the origin. So that doesn't work for me because I know that my inflection point should be somewhere to the right of the y-axis, similar to my inflection point on the graph of f. Hence the only graph that works is the graph of IV, and since f dash was a quadratic function, an x power 2 function, I expect f double dash to be a linear function or an x power 1 function. So take a minute to copy this down if you will. This concludes our answer to question 2, and I shall begin question 3 shortly. So our third question came in paper 1, May 2014, time zone 2, question number 6. Kindly take a minute to pause the video, attempt to solve, and then wait for the explanation shortly. So I shall begin by analyzing the graph of f that I was given. Take a look. So the graph, I am told, has a local maximum at A where x equals negative 2. So this is A, this is my maximum, and the local minimum at B where x equals 6. This is my second stationary point. I already know this from the graph. I am asked to sketch the derivative function f dash of x. So I'm going to use the information that I have written down on the graph of f. I know that I begin by being positive until a, where x equals negative 2. So at x equals negative 2, f dash is 0, so I have an x-intercept right there. And before that, I am positive. After a, f dash is negative, as you can see, throughout this region from a to b, f dash is negative. And at b, which corresponds to x equals 6, f dash is again 0, so I have my second x-intercept right there. And between them, we already mentioned that f dash is negative, so I expect my graph to be below the x-axis. Finally, after b, f dash is positive for the rest of the graph, so I expect f dash to be above the x-axis because f dash is positive. So this looks like a smiling face, a concave up parabola, a quadratic function. These are all terms to describe the curve of f dash, and it should look something like this. So this is the marking scheme version of f dash, and as you can see, it goes from positive there and there to 0 at x equals negative 2, and then negative, as we said, then 0 at b where x equals 6, and then finally positive after that. I've also attached the marking scheme instructions of grading so that you know what the marks are for. There are 4 marks in this question. You receive a mark for circling the first x-intercept corresponding to the stationary point at x equals negative 2. Second mark for circling the second stationary point, x equals 6. You get a mark for an approximately correct shape, by which they mean a quadratic function, and concave upwards parabola, And finally, you get a mark for making sure that the y-intercept is negative, which shall happen automatically if all your other values are correct. So let's move to question B. Question B says, write down the following in order from least to greatest: f of 0, f dash of 6, and f double dash of negative 2. So f of 0 from the graph is right there. So f of 0 is a positive value. The y value is positive, it's above the x-axis. Whereas f dash of 6, so when x equals 6, f dash is 0. So I know that this is a positive value and that this guy is 0. What about f double dash of negative 2? F double dash of negative 2 is the value of f double dash when x equals negative 2. So at this point lies in the region where f double dash is negative, because the curve is concave downwards. Hence, this third point is negative. So even though I don't know the exact values, I know that the first value is positive, the second is 0, the third is negative. Hence, it is easy to arrange them in ascending order. Take a look. So the order shall be f double dash of negative 2 less than f dash of 6 less than f of 0. This is not 0, this is obviously f of 0, forgive the mistake. And this is my final answer. So take a minute to copy this down if you will. This concludes our answer to the third question as well as this video. I hope you have found it useful. Thank you.